Polynomials are expressions that contain several algebraic terms with coefficients, variables, exponents, and constants. For example, a polynomial could look like this: 10x squared plus 22x fourth plus 4x cubed plus 10x plus 5. Typically, polynomials are arranged by the term of the highest degree. In this case, this term has the highest degree since the 4 is bigger than the 3 and the 2 and the 1 right here. So we can rewrite this as 22x to the 4 plus 4x to the 3 plus 10x squared plus 10x plus 5. Polynomial functions are always continuous. This means that there are no gaps at all. Polynomials can also never have negative exponents, so something like this. They can never have variables in their roots, something like this, and they can never have a constant raised to a variable. There can also never be any of the variables in the denominators, so something like this. A good way to determine how a polynomial would look like when graphed is by using the leading term test, the LTT. Using this test, you look at the first term of a polynomial, or the leading term. In this case, let's have 10x squared plus 4x cubed plus 5. In this case, the leading term is the term of the highest degree, 4x cubed. Cubed means that it has an odd degree, and the positive 4 means that there is a positive sign. In this case, this polynomial would mimic a cubic, which looks like this, x cubed. If this was an even degree, it would mimic a quadratic, which looks like this, and this would be x squared. If this was negative instead of positive, it would look like this. This is a negative cubic, while a negative quadratic would look like this, negative x squared. Based off of the leading term test, we can make a graph which takes into consideration even and odd degrees and positive and negative coefficients. We can accurately graph a polynomial based off of its leading term. So let's look at negative 5x to the fourth plus 2x plus 4. This is the leading term and it has a negative sign while it has an even degree. This means that it would mimic a negative quadratic, which looks like this. Let's look at another example. Negative 6x cubed plus 6x squared plus 3. This is the leading term. It has a negative sign and this time it has an odd degree. This means that it would mimic a negative cubic, which looks like this. Finding the roots of a polynomial can be done by setting it equal to 0. So f of x equals 0. According to the fundamental theorem of algebra, or the FTA, the leading term's degree says that there are at most n zeros. This means that if we take, let's say, negative 7x to the fifth plus 6x to the 3 plus 2x plus 5, there are at most 5 zeros in this polynomial. This means that it can hit the x-axis at least 5 times. And this may be real or imaginary solutions. Multiplicity is another important concept to know. Multiplicity. This tells you when a curve bounces or crosses through the x-axis based on the number of times that its roots appears. So number of times its roots appear. Odd multiplicities, or roots that appear only one time, cross through the x-axis. So if this was the x-axis, the polynomial would cross through like this. If there were even multiplicities, it would bounce off of the x-axis like this at its roots. Knowing all of this, we can predict how a polynomial would look like when graphed. Take this function for example. F of x equals x to the fifth times 3x minus 6 squared times 4x plus 8. To find a leading term, you take the terms with an x and multiply them together while adding their exponents together. This one, and this one are all terms with x's. So you do x times 5 times 3x squared times 4x. And you will get 3 squared is 9, times 4 is 36, and then x to the power 5 plus 2 plus 1, which is 8. So this is the leading term of this polynomial. This has a positive coefficient and an even degree. This means that this polynomial's end behavior would look like this, since it mimics an even and a positive quadratic. Next, we have to find the roots of the polynomial. Since this is already in factored form, you can just set each of the terms equal to 0 due to the zero product rule. And 4x plus 8 equals 0. X to the power 5 equals 0, so x would equal 0. 3x minus 6 equals 0, so 3x equals 6, and x equals 2. And 4x plus 8 equals 0, so 4x equals negative 8, and x equals negative 2. Next, we have to look at the multiplicities. 0 appears 5 times since of the degree 5. This means that it would cross through the x-axis. 2 appears twice since this is to the second degree, so it would bounce off the x-axis since it is an even multiplicity. And negative 2 appears once, so this would cross. Knowing what the end behaviors, the roots, and the multiplicities are, we can finally predict how this graph would look like. Let's say this is the x-axis. At this point is negative 2, at this point is 0, and at this point is 2. The end behavior looks like this, due to the leading term test, so we can automatically draw that in. At 0, it crosses, at 2, it bounces, and at negative 2, it also crosses. So at negative 2, it crosses, at 0, it crosses, and then at 2, it bounces off. So this would mean that this polynomial would look like this. Graphing this on Desmos, we can see how it starts here, it goes down to negative 2 and crosses, it goes back up to 0, crosses at 0, then it goes down here, bounces at 2, and then goes up continuously.